until.
So anyway, we're going to check our stuff. Open up your packets, 3-1, and check yourself before you wreck yourself. Make sure that you actually did it right. Okay. Collectively, I believe we said that this went well and we felt confident. But double check things. The likelihood that maybe we got our y-intercept correct, but we went in the wrong direction with our slope because we're not putting those arrows on there, like I've been saying. 85. Yep. In the back, where they always are. We good? Do we need to go through any of them?
Yeah, I got 13.
13 went iffy? Okay, start with, what's y-intercept? Yeah. Y-intercept. 1. And then the slope is, careful, -2/1. So are you headed up or down? Right 1, down 2. Right 1, down 2. Right 1, down 2. Do you got your little arrows next to the -2/1? Okay. Like, I heard that Mr. Skoglund was also a little bit of a stickler on this, whether you're saying right or left, not just over. Y'all, that's a big deal. Okay, you say right and then up or down. If you always go left to right like a book, the sign tells you which direction you're headed. Okay, next page. 1516, checky checky. So far, we've been lucking out that the scale on most of our graphs have been going by 1. That is not always the case. If they start changing the scale so that maybe the x's go by 1s, but y's go by 2 or even 4, 10, that changes things. Anything about these? Good. Okay. Then, Hodo words. Okay, 17 was just blah, 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 do the same thing, right? It just had word context with it. 18, there was a couple of us that asked this one. And we found, I think, collectively 3 different ways that we could have figured it out. Everyone's got their y-intercept of 400. But how do I get more points? What? Scissors over there. We know that the slope is -18, right? But how do I take -18, meaning right 1, down 18? How do I do that when my y's are going by 100 and my x's are going by 5s? You can change that. That was one of our ways. Where, well, if my x's are moving by 5s, what if I just multiplied both these by 5? Then I'd get down tonight. I'd go down 90 and over 5. That would be a little bit more manageable. Could you ballpark down 90 and over 5? Down 90 and over 5. Down 90 and over 5. Okay? That would be a lot more manageable than 18 and 1. You could have also changed that to go by hundreds and whatnot. Another way would be to just find one more point. Real easy. Pick one of these numbers, right? That's how we do tables. Is we always pick numbers that are on the graph. So just pick another point somewhere on the graph. Pick, I don't know, 20. And find the y that goes with it. If I say y is negative 18 by 20 plus 400, get negative 360 plus 400 is 40. I can plot the point 20, 40. 20, 40, I can kind of ballpark it. I already have my y-intercept, and I can connect the dots. Okay, so if the scale gets weird, you might have to wiggle it a little bit. Yes, sir? Yeah. The other one I saw, which is a little riskier, I do not recommend this way, but I don't know, maybe you could just write really, really tiny. You got really, really good eyesight and hand-eye coordination. Is I had a kid who actually ballparked down about 20 over about 1. About 20 over 1. About 20 over 1. About 20 over 1. About 20 over 1. And he did that all the way down. I don't recommend that because you're estimating, and y'all know what happens when you estimate your estimate, right? When you say good enough one time versus you say good enough and then good enough and then good enough, pretty soon it ain't good enough, is it? Okay, how many times in a class? Close enough. Close enough. I can put IDK for this one. Doesn't that start to pile up? Okay, so he got there. Like, he was very meticulous about it, but I would not recommend that way. I'd say change the slope, Jesus fish style. Okay, our vocab. Vocab is always on that first page of the section. Just plug her in there. Easy peasy. 22. They ask the question, what if I gave you a point besides a y-intercept? No, but fix, but whoever it was, fix it. Then turn it off.
Put it on do not disturb. Give me
Y'all.
Just gonna power it off.
Yeah, off. Kids are always like, well, what if my mom calls me? What if my mom texts me? Yo, we got by decades, generations without that. There's a phone in the office. If someone's dead, they'll call them. Okay? If you got to go for an appointment or something, they're going to call down there anyway because they got to call Pam to get you out of here. So just, all right. They're asking, what if I gave you the slope like 2/3 and I gave you a point besides the y-intercept? What if I gave you this point? Could you still make the graph? Can't you still count 2, 3, 2, 3, 2, 3 from there? You saw that last year. It was called point slope form. This guy look familiar? It was actually super easy. You just had to remember that because that y1 x1 were paired with something, it was bass-ackwards. If they said -5, it was really +5. If they said +3, it was really -3. Like, that was the only thing. So, just so you know, that is possible. Okay, I might talk a little bit more about point-slope form later, but for now, as long as you can do by slope-intercept and we pound the living snot out of it, I think you're fine. Okay? If we okay with that, nope, not you. Go away. You, where blank graph? There's a blank graph. I just need a blank graph up here. Then 3.1, slope-intercept form. I would like you to graph and label. Label? Nope. English is important, but math is importanter. Okay? Okay, now somewhere in the back, y'all, sorry, I didn't have the graph paper when I was making the copies, so it's all just like blank. If you feel confident that you can make a graph accurately and neatly enough, then go for it. If not, grab yourself some graph paper from over there by the calculators, just staple it on the back and you're fine. Okay?
This will be 3.1b, but in 3.1 last time.
Oh, we already did one?
Yeah.
Wait, did you do 3.2 already?
No, we're on 3.2 now.
Yeah, we did this one back. I got it. I did this one, brother.
Oh, because you guys took because of the early out yesterday, that crew did 3.2. Their quiz isn't going to be until tomorrow. So everything was just all messed up. Okay, so you've already done yours. Sweet. So you're already done with it. Cool. I knew that this whole week was going to be messed up because of that. Doing a quiz during an early release week. Yeah. All right. You good then. In that case, 3.2, here we go. If you can graph a line in slope-intercept form, you can do everything today. Because it's not new information. I'm curious. Who knows what that blue and orange line actually are? They do intersect, but what are they? Like, what is a graph? That blue line is a graph which represents what? It has a slope on it. Okay, I heard linear. It's a linear equation.
It represents something.
Yes, it does. Okay. Maybe this will help you. This point right here is at -1, -5. If I put in -5 and -1, is that a true statement? What's 3 times -1? -3. What's -3 minus 2? -5 equals -5. This point is a coordinate that makes that true. So what's this point? What's 3 times 2? minus 2. That point is an x and a y that makes this thing true. So what's this? And this, and this, and this, and this. They're all coordinates that make this equation true. That's what a graph is. It's everything that makes it work, everything that makes it true. And there's an infinite number of them, right? I can pick a really stupid x if I want to. I can pick 2.81953 over pi and throw it in, and I'll get a y that comes with it. And that is a point that makes this true. So if the blue line is all of the coordinates, everything that makes that true, what's the orange line? All the things that make what? Blue line is everything that makes blue guy true. Orange line, everything that makes the orange equation true. Natural consequence. What is pink dot? When they're both true. Y'all remember doing systems? You should have ended on it last year. Think about it this way. Blue line. My wife wants Mexican food. She just got a hankering. Orange line. I hate Mexican food. Can't stand it. I'm a texture eater. Like all the rabbit food in there, like the tomatoes and lettuce and God, refried beans, don't get me started. I'm a sissy when it comes to any form of spice. Salt, pepper, butter, ketchup, done. Anything more than that, my mouth's on fire. Pink dot, Guadalajara's. Because she can get her Mexican food and I can flip it over to the gringo menu on the back, get a chicken sandwich and fries. Okay? This is the one place where we're both happy. It's the one place that they're both true. Okay? It's like finding, going to a bigger city and finding one of those fusion restaurants that's like, I don't know, Korean food plus Salisbury steak. Like,
I went to this Hawaiian restaurant in Chicago.
fusion restaurants got weird stuff, and it's weird stuff that makes people very happy. This is called a system of equations because it's got more than one. And if I want to know what the solution to it is, I graph them both and see where they're both true. That coordinate, that 1, 1, is the only thing that's going to make this true. Three minus 2, 1. Negative 2 plus 2 is 0. That ain't right. They have the entire wrong equation there. Oh, this is supposed to be negative 1x. Way to go, book. Okay. So, I will be mad at the pirated content. I paid nothing for that.
Then why are you bad?
Because I'm not getting my money's worth. So, this idea that it's the one place that makes a set of equations true, well, what happens when I go and graph this one, and then I graph that one, and then they never cross? No solution. There isn't a solution. You remember what those are called? Lines that never cross, that never touch, like train tracks. It's even right there on the, okay, parallel lines. Parallel lines is really easy to remember because that double L in there literally has the double line train tracks, right? It's right there in the word. So sometimes I'll graph them and they'll cross. I get a solution. It's where they're both happy. This, I don't know. I want a peanut butter and jelly sandwich and my wife wants lobster. Like, what restaurant am I going to that's got both? Right? Okay, it's just not happening, at least not around here. Okay, if I might be able to get that peanut butter and jelly off the kids menu if I'm lucky. I think I've gotten that for my boy at Perkins before. Okay, they bring out the Uncrustables. Yeah,
Can't even have peanut butter.
right. You will know all kinds of shame as a parent, and one of them is paying good money for what's basically Easy Mac. So, stop it, Frank. Frank, dude.
Are you good? He's not responding. We gotta resuscitate him. Oh!
Okay, I didn't actually expect that to work. Come on, Frank. Come on.
We get killed him. Just a few good chest compressions. We'll be okay. Yeah.
Frank's about to get a chair through the face.
Frank, you got me nice, buddy.
Okay, there we go. And then sometimes I graph a line, and then I go to graph the next line, and they land right on top of each other. What you got to be careful about, remember when we would do like, and then down at the bottom we'd get 5 equals 5. When you're solving an equation, junk equals junk, blah, 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 I did math. I get to the end and it says 5 equals 5. Is that a true statement?
Yeah.
Okay. We used to call these, now with equations, you would say all real numbers. What if I do math equals math, blah, blah, equals blah, 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 equals blah, 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 get all the way down the end, and you get 5 equals 0. Is that a true statement?
No.
So what's my answer?
No real number.
No solution.
Sorry. No solution.
Okay. So we can see those, but if they're the exact same line, I can't say all real numbers. Because, is that a solution? So it's not all the numbers. It's just an infinite number of numbers. Because these go on forever, right? They go on forever, so I have an infinite number of solutions, but it's not all real numbers. Not everything's an answer. It's kind of like when you have that argument with someone, and you're like, you're not wrong. It's not the perfect answer, but you're not wrong. Okay? Or when someone says, there's a bunch of right answers. Does that mean I'm always right? No, because you can't say thing. It's like when teacher says there are no such things as stupid questions. I want you to ask questions. No, there's such a thing as stupid question. Because immediately after that, a kid's going to say, isn't Star Wars the thing with the lifesavers? Okay, now that's a stupid question. Go in the corner and think about what you just said. So,
You offended the nerd god.
right? So be careful with these. We call them infinitely many solutions, not all real numbers. And if you can graph, then you can do all of these. The first one is basically just, can you graph? Okay. Can you graph 2 lines? You better be able to. Okay. Contestant 1. Contestant 1. The slope. Uh-oh. I don't see a number. I just see a negative. The y-intercept is 3. What number is in front of x? Negative 1. How do I turn that into a fraction?
Put a 1 underneath it.
And then that slope, again, I always go left to right like a book. Negative tells me head down. So I'm going to start at 3. I'm going to go down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. Or I can reverse the flow. Up 1, left 1. up 1, left 1. And I am going to make as many dots as possible. I know when we were graphing these last time, several of us were saying, well, do I really have to make that many dots? No, as long as you got 3 so you can make sure you're lined up, you're good to go. But sometimes you want to make as many dots as possible because one of those dots is probably my answer. Graph the other one and you should hit one of those dots. So orange, there we go, orange. Slope.
2/3.
2, not over 3.
Over 1.
Over 1. My y-intercept is -3. I always go left to right like a book. +2 tells me we're going up. So from -3, I'm going to go up 2, right 1, up 2, right 1. Aha! Up 2, right 1, up 2, right 1. Okay? That's why I want to make as many dots as possible. Because one of them is probably my answer. I'm going to make 2 dots in the same spot. So I got my 2 lines. They intersect at a point. If they intersect at a point, at 1 point, that is my answer. Make sure that you label it correctly. If you need to put your little cheater next to it because you tend to goof these up. If you got to put that cheater on there, make sure you do it. Intersection is at 2, 1. So that is the one place that they're both happy. Okay. Y'all are in here maroon too. How many times do you start talking to your friends like, where are you going for lunch? Where are we going for lunch today? I don't know. Where do you want to go? I don't care. Where do you want to go? Dude, I don't care. Where do we want to go? And you just argue and you argue and you argue, and then eventually you go to the same place that you go every day. Right? Assuming you leave for lunch. Down low. You try it again. Come on, Frank. Let's go, Frank. I say slope is 4, y-intercept is 2. Make dot at 2. Slope. Uh-oh, I only see a 4. Over 1. If you got to put your little arrows on there to tell yourself which way you're headed. Up 4, right 1. I'm okay going 1 box off-road. I wouldn't feel comfortable going 2 or 3 boxes off-road. I don't think it's accurate enough. I only got 2 points on there, and one of them is off the map, so it might not be accurate. But if I can go up and to the right, I can also go down and to the left. That's where those arrows can come in real handy. We're going to go down 4, left 1, down 4, left 1. That one's a little bit off-road too. I connect dots. I move on to contestant 2. Slope is 4, y-intercept is -5, dot at -5, right on the map edge. And so, wait a second. The slope's 4. Again.
Oh.
So, do we already know what my answer is going to be without even graphing this?
No.
Because if the slopes are the same, they're parallel. Okay, that was something that should have been kind of pounded into your head last year too. If I go up 4 and over 1, up 4 and over 1, these 2 lines are never gonna cross. It's like train tracks. The lines are parallel. So the slopes are the same. So there is No solution. Okay. Flip it over. They're going to start with just a little bit of practice making sure, because it has been a few days. Can you graph lines? Like, can you start to finish graph lines? The first two are just graph it. That's it. Just double checking. Can you graph lines? The next four are already graphed for you, but you have to tell me what the answer is. There are two equations graphed, and you have to tell me what the solution is. Okay? Argue it out with your neighbors, those 6. Graph some lines. Tell me some solutions for the other 4. Yes, sir?
There's no y in
So what do you write for nothing? There you go. Put your arrows next to it. Denominator is always to the right. Dr. Magoose.
Could I do that? Could I just put
Yeah,
0?
because there's a
Yeah.
+0 out there. Yes, sir. That is absolutely what you do. Mm-hmm.
I can only graph 2 points.
Sometimes that's all you can fit on the graph.
Okay.
We would prefer 3, because then we're sure to be right.
Yeah.
But sometimes 2 is all you can fit on there.
So what do I do for my y intercept?
What's the number for nothing?
0.
Yes, sir. On this one? Where do they cross? And this is, remember when I said we're going to have to start being careful about our scale? You're right about that. That's halfway through. There you go.
So what would be the solution? Just these?
Yeah.
Okay.
Where they cross is the solution. Like, the solution is go to Guadalajara so you're both happy. I got to be careful what I say about Guadalajara's because I've had several of their kids in my classes before.
There's 2 of them.
Okay.
Yeah. There's one in my grade and the other one's a sophomore, I think.
Yeah.
I just.
Look, we lived in Arizona for 3 years, I think. My wife got hooked on real Mexican food. Like, no one there speaks English. You point at something on the menu, hand them $5, and they give you like a container full of glory. Like, you open it and there's angels singing kind of food. And she got so hooked on that. There's a difference between that and Midwest Mexican food.
Yeah, Mex-Mex is not great.
There's a difference. So
I just do like a 1.5
and sometimes you're gonna have to ballpark it. Yep. We're gonna talk about it, but yes.
So there's like, it's not really.
You gotta ballpark it. So about what?
How long has it made it for a while?
1.
Cause she just made it
You can use decimals or fractions. I'd say about 1 point, about halfway, right? You can say about 1.5, comma, what? Oh, 0.5. There you go.
There's like, they intersect at weird points.
This one, watch the scale. What's halfway between?
9.
Yeah.
9, -6.
Other way.
6 negative 9. I'm very smartles.
Negative 6.
Last year's question.
Oh my god, I'm so smart.
I have a photo for that. I have a photo of you like this with like.
I know you mean that disparagingly.
No,
I'm a wacky with the dinosaur if you keep talking like that.
Ugh.
Okay?
Okay. And
Yeah.
then they
You just have to check this.
and
They
then-
intersect at the point,
Yeah, because those stick open at.
so that's my answer.
Oh, okay, so you just drew
Yep.
it like twice. Okay,
Yeah.
that makes sense. And then it's the same
That
with
one you
the-
got a ballpark. You're going to have to estimate that one. Very close. Okay. We sound like we got this. Fairly quick. Slope is negative 1, 6. Y-intercept is 3. Frank. I blame you.
Why? Is it because of my brother?
No, it's because of you.
Why?
Sullivan, if you think if there's anybody to blame, it's me.
Actually, I think I'm going to blame this one at Lars. He was throwing that squishy around this morning, and I saw it whack the board. Not nearly as hard as someone beating it to death with a marker, but... so I'm going to start at 3, and my slope is down 1, right 6. And a couple of you asked this. I only have 2 points. Like, is that even okay? Sometimes that's all you can fit on there. But you can make a third. If I go down 1 over 6, what if I divided this by 2? Couldn't I divide this by 2? I know y'all don't like compound fractions. You don't even like regular fractions. But could I go down a half a box and over 3? Just to make another point. That's okay. Sometimes you gotta get creative like that. I connect the dots, you're good to go. Contestant number 2. What's the y-intercept on this? 0. I didn't write, there was nothing there, so I put a 0 as a placeholder, and now it's no biggie. 3 over 1 to the right and up. Start at 0. Up 3, right 1, up 3, right 1. I can go off-road. Down 3, left 1, down 3, left 1. I can go off-road. Connect dots. Yeah, that was a pretty straight line. Good job, me. Okay, these ones you're just telling me what the solutions are. 4 and 6 we better know because I just look at the front page and it tells me. If they never cross, what's the solution? There isn't one. What's that called? Parallel lines. Okay. If it says the lines are, like plural, and then there's only one line. So what are the lines? Infinitely many solutions because the lines are the exact same thing. I told you to be careful that we're about to start seeing different scales. This point, I'm betting we had our negative 6, but be careful about your scale. What's the y part?
Negative 9.
Negative 9. And that number isn't even on my graph. I just have to understand they're going by 2's. So halfway through the box is halfway in between negative 8 and negative 10. Okay, you're going to have to be, what's the word there, Tian? Smartles?
Yeah.
Okay. 5, you also have to be smartles because it's not in a nice place. Like those 2 lines cross kind of out in the middle of nowhere. But I can estimate it, can't I? So I would say about 1.5, 0.5, or about 3/2, 1/2. Like that's the same thing. But since you're not sure, because it doesn't hit a nice point, I want you to put approximately next to it. Y'all remember approximately or about? It's like a beat up wiggly equal sign. It means close enough. Sometimes you got to do that. In fact, you get higher up in math and we do that an awful lot. Where we'll write the correct answer, but the correct answer is a compound number that the layperson isn't going to understand. You know, sometimes I walk into the home center, and when I belly up to the counter and say I need stuff, I'll tell them the exact amount of stuff I need just to mess with them. Yeah, the trim gutter on the west side of my house is messed up. Do you have 85 square to 2 feet of U-channel? You know what happens when you do that to the guys at the home center? Their eyes get slightly cross-eyed, the left one twitches, and then they grunt at you. Huh? So then next to that, I would put approximately, and I'd give the decimal approximation. Okay? That's going to happen more and more as we get through math, where I don't want the fully correct answer when I'm talking to most people. Also, what happens when this is in a really goofy spot? What happens when it's like there? Right? You would have to guesstimate that. And that's why in chapter 4, we're going to talk about solving these systems. Y'all remember substitution elimination? I hope. Okay, 7. Who feels brave?
Brave for what? I do.
You got this?
Yeah.
All right. Teach me, youngling. What's up, dude? Why'd you do that? I grew up like 80s, 90s. Like I can Valley Girl real good. Like, oh my God. I grew up in that era. Why are you writing that though? I don't hear any explanation. You were supposed to be teaching me. I'm sorry, what there, Chuckles? Okay. You should be able to explain stuff. It's not enough to just do the thing. You have to be able to explain it. Why did you put a 1 there?
I put a 1 there because there's a 1 in front of the X.
Okay, we always have our invisible 1, right? Otherwise, I wouldn't have written it at all. Well, why'd you put it over 1?
Because it's over 1.
How'd you know that?
Because it goes over 1.
This definition brought to you by the Redundant Department of Redundancies. Okay, yes. Y'all, you have to be able to explain what you're doing. There's always an invisible 1 in front of the X as a placeholder. I can make anything into a fraction by putting it over 1. Continue. Okay. I like that you are putting the arrows on there, though. How many of you did the arrows for the test on Tuesday and like you felt like it made a difference? Oops, that's right. I go this way. I hope so. Like I hope, genuinely hope that makes a difference for you, and that's the big switch from this year to last year about getting these right. You make as many points as you can. The more points you make, not only the more accurate your line, but there's a good chance one of those is going to be your answer. Okay? Connect the dots. This is a pretty straight line. Not bad. Now this one, if you start at 4 and start going up 2 over 1, it looks like it's not going to hit it at all. But if you back up, down 2, right 1, or left 1, yeah. Down 2, left 1. There you go. But if you reverse the flow, then you will see where they actually cross. Do y'all feel like this is pretty much just repeat of last time? You just have to remember whether it's one solution, no solution, or infinitely many.
So
You think you could take it from number 8 straight through to the end zone?
stuff's easy.
Get it. There are words. The words usually have an equation next to them. Okay? Be careful. Okay? Now, Elise, if you had done this on, I don't know, a daily check on Monday, 4 out of 5. You have to tell me where they cross. If they cross at a point, you have to actually tell me what the point is, because that's the answer. Okay. Yeah, if y'all are good with it, I'll just turn on some jams and we will practice graphing lines. When you hit the stop sign, you're done. Cool? Quizzes. Tegan, I know you have to finish that one. And who did not take theirs? I know you were going to come finish yours. Anyone else?
Yeah.
Everyone else took it? You're good? Okay. Grading them? Oh, sometime. Y'all, I can't do stuff at home. I can't work at home. Like, my parental responsibilities preclude that. So it's just whenever I get time or whenever I choose to sacrifice sleep. Okay? So I'll get them graded at some point. Y'all know the drill by now. I'll send out that cute little chart on Remind, show you how everyone did on that quiz. I would like them all to be done so we don't have so many incompletes. And I think I told you that our next quiz is on the midterm, right? So 1, 2, 3, 4, 5. Yep. So the 16th, February 16th, Thursday, is the third quarter midterm, and we will do our quiz that day. Okay. It's also right before a 4-day weekend, so that'll be cool. No homework and 4-day weekend. It's also, if any of you want to get your nerd jam on, that Saturday we're going to do our next geekathon. We've had our hiatus for a few months now.
What's the date for that grade check? Like the 24th or something?
The 16th is end of the quarter, and the 22nd will be when the grades come out. Usually it's the Spartan time right after that it takes effect. So 24th. Yeah. Also, that 22nd is the day that y'all are doing your pre-ACT, or most of you. We had at least one junior in here, right?
Just Leslie, I think.
Just one?
No.
2? Okay. So on that day, 3? Oh, question. On that day, I'm pretty sure that you're just doing it in the afternoon, so you should still be here in this class. But if the pre-ACT goes the entire stretch of day instead, then we would just hang out and play games.
So if I say,
It doesn't work with only like 2 or 3 people. You need a bigger crew than that.